Phil, it finally happened. I have received the resin I need to make the actual DOE on my 3D printer. And now this is not an unboxing channel, but look at this. There it is.
Ooh.
Now, yeah, exactly. So when I say 3D printing, people think of another kind of 3D printing. So I always have to explain to people that's not it. Because when people buy a 3D printer, they buy a filament printer. I have a resin printer. Filament printers, they're you have a hard filament and you have that nozzle going around, where resin printing has more magic to it. You have to shine UV light on this liquid resin that is very toxic. So gloves, masks, everything. I need to post a picture of how beautiful I am with all that on. So just to clarify, that's the kind of 3D printing we're talking about.
Yeah, complicated stuff. Chemistry by the sounds of it.
Very much chemistry by the sounds of it. And I had people reach out to me on LinkedIn saying why this doesn't make sense. I'm going to do it anyway. So we set up a DOE last, and the resin was, for various reasons, a very long time to get to my house. So I had time to think on the DOE setup. And that's always a good thing. Like when you're in the beginning of a DOE, putting thoughts in at the initial is valuable, because when you've started, right?
Yeah, somebody that I know once said, think harder before you start. And that was their big piece of advice for DOE. And I just completely agree with it. You really should spend a good amount of time planning, thinking about what's important, being clear about your objectives, and all the factors and things that might need to go into your experiment.
Like even just adding a single factor, if you have a 21 design, you basically need to start over.
Yeah, you can augment with new factors, but it's not ideal.
These are the factors where I identified last time, and I didn't omit any of them because I thought, why not just add them all? But thinking about it, I realized one of these are hard to change, because the printing temperature, or the room temperature that I print at. Well, I have a controlled environment, so it's possible. But if I have to change the temperature from 30 to 20, it has to stand in there for some time for everything to adapt, right? So I don't want to change that every time. It'll be. Can we take that into account in our design?
Yes, absolutely. And this isn't a good example of the kind of real life practical constraints or challenges that we have when we're doing experiments. And that means that we need to be flexible about how we design our experiments, and we need to have good ways of dealing with these kind of practicalities. So this is going to be something we would call a split plot design.
And why would you throw such a word at me?
It's a good question. It doesn't really make a lot of sense when you're doing 3D printing or when you're designing, a new pharmaceutical product. It comes from the world of agriculture. So a lot of design of experiments, a lot of the methodology was invented or discovered in the world of agricultural research. So they were talking about plots, literally plots within a field, and how you randomize the treatment factors across those different plots. So it's a weird word for it. It's not great.
Okay, so you would actually literally split the plot.
Yeah. And within one plot, you'd have some factors that change, and you'd have some factors that are the same across the plot. So some factors are harder to change, so you can't change it within a plot, but you can change it between different plots.
Okay.
And there's an analogy here. So temperature is an example of a factor that is hard to change. You can change it a bit, but you can't change it each time. You can't change it every time.
Yeah. I mean, there might be a situation. So mine, I'm just lazy. I could do it.
Yeah, me too.
Right. I could literally make it every time. So it's just a matter of time. But you could be situations where it's physically impossible. Or like, that's how it is. My setup is made in such a way I have to run 5 runs at a time. And within those 5, you would then have changes, right?
Yeah, and another good example within the world of real science is in biology, when they're doing things on well plates, 96 well plates, 384 well plates, there's factors that they can change within a plate, but incubation temperatures and things like that, they can only, the factor has to be the same for the whole plate. So there's plenty of examples in the real world of science and engineering where these hard to change factors come about.
So the one we're talking about is these changes. And if I click on this, it has a very non-mathematical term. It actually talks about easy, hard, and very hard. It's not very quantifiable. So I don't know which should I say. This is very hard, or this is just hard.
Unless there's something that is even harder to change, then hard is fine.
Okay, so if you have multiple hard to change factors, you can label them.
Yeah, then you get into split plot designs, and I don't think we want to do that today.
So I'm just going to set that to hard. So if I just want to do a main effect, like a classical screening,
right?
What more would you need for me to do?
Well, you don't need to. You're just going to estimate the default main effects model there, so that's all fine. But you see now you've got a choice about the number of whole plots. So this is the number of, effectively the number of times that you're going to change that hard to change factor. So within a whole plot, printing temperature will remain constant, and you'll be changing the other factors. So this is where you can decide what's practical in terms of the number of times that you can actually practically change that printing temperature.
Okay, but I guess there's a limit, because I said, well, actually, I just want one whole plot. That doesn't make sense, right? So
no. You're just going to have one temperature and people learn nothing.
Yeah. How about this? That's the same as just removing it, right?
Basically, yeah.
But if I put that at 3, doesn't it come up with a warning?
3 should be okay, I think.
But 18 is a lot. Why would I do 18 for just if I wanted main effects? Like a total classical screening.
Yeah, 18 is quite a lot, but you do have quite a number of factors here.
That's true. So how would I know when enough is enough? I think that's a question I get all the time.
Yeah, well, it's always the case that more runs is better, but it's diminishing returns. So, if you've only got a small number of runs, an additional run makes a big difference. If you've got lots of runs already, then an additional run makes a small amount of difference to your power to detect the important effects. It's really difficult to give a definitive answer to this.
Without having a high degree of subject matter knowledge. Like if you really understand how important you think these are, I guess you could go and calculate how many runs you would kind of need. But if you have no knowledge, it's almost impossible to say, right?
Yeah, you need to have a really good understanding of what size of effect that you want from each factor. You need to be able to detect for each factor, and a good sense of what the noise is. So if you just ran the same factor settings 100 times, how much noise would you expect in the response? How variable would the response be? And most of the time, we don't really know either of those things particularly well. And even when we do, you still just end up with a probability of being able to detect the effect. That's what power is. So there is no certainty. That's just not possible when you're doing experiments.
I think that's true. So if I were to just create this design.
Yep.
And you're saying if I take my printing temperature, put that on the side of whole plots, I can see if I select whole plot 1, I only have a high temperature, and I can see that within those, I have the high and low setting of layer height, high and low setting of exposure time, and so on and so forth. So everything is changed within that whole plot.
Yeah.
Everything is changed within whole 2 and similarly with whole plot 3. So that is imagining we were having 3 fields or one big field, splitting it into 3 portions.
Yeah, exactly.
And I mean, I can understand that picture. So why don't I just do this with all my factors? Since my DOE would be easier.
Well, experiments are all about learning about the effects of the factors, and we learn about the effects of factors by changing them. We can only understand what the effect of changing a factor is by changing it and looking at what happens to the response. The more we change it, the more we learn. So the fact that we're only actually changing this factor twice within the experiment means that we can't really learn as much. We can see, we'll be able to compare the difference between printing temperature being at 35 and being at 20, but we've only changed it twice. So we just don't have the same amount of data to back up what the effect of that factor is. Ideally, we would change it every single time.
So that's really where like randomization comes in. Like saying, okay, because this was like, this is what it is, I couldn't do it differently. Here's the design you can make, but it's really not optimal. That's not what we would hope for. Well,
it's a compromise. So
yeah.
In this case, it depends what you mean by optimal. It's less effort, which is maybe what your idea of optimal is. It depends what you need to learn about that factor.
Yeah. Well, that comes down to it's actually quite difficult to find a good response to measure.
Yeah,
okay.
And you might want to. It sounds like you might want to have it there for later augmentation, so that you can, really find what the optimum is between 25 and 35.
Yeah.
Or how it interacts with other factors as well. Maybe, I don't know.
The last time we set up the design, we spent a lot of time discussing the importance for me to be able to augment the design.
Yeah.
And I had that in mind because I wanted to start as low as possible, just to maybe root out some strong effects, and then maybe add on some runs to find curvilinear. Having these kind of whole plots, would that ruin my ability to augment?
No, it shouldn't do. I mean, there's all sorts of practical constraints that we need to consider when we're doing an experiment. And you really need to be able to design the best experiment that takes into account those practical limitations of what's possible. I'm a big fan of sequential design, so we don't try and learn everything from the first experiment, from that one-shot experiment. So if printing some temperature is something that you need to explore, and it's a hard to change factor, then you should design the experiment allowing for that, and then we'll worry about the augmentation later. Okay.
If I were to augment, let's just say I've run out of this and I realized I wanted to add curvilinear. The idea would go to DOE, augment design, right, then adding my Y as the Y.
Yeah.
All of these as factors. I have the ability to augment.
Right. And it's remembered that printing temperature is hard to change.
But it doesn't allow me to, so here's, if I should go in here then add powers. So if I make the design now.
Yeah, it's going to add an additional 8 runs, and hopefully you should see some settings of factors that are between the low and the high extremes.
So I've added 2 new whole plots, 4 and 5.
Yeah.
And one of them is at a middle temperature, which is totally new. We've never done anything at 27.5. And that within that middle temperature, every I have it other of a setting at the. So that's quite beautiful. What do you think of this new design?
So again, it's a compromise. I mean, we've only got 2 additional whole plots here. You're only changing printing temperature once within the augmentation runs, which again, it's not ideal. We would really like to change temperature from a statistical power point of view. We'd like to change temperature between every run, but from a practical point of view, this is great, right? You can set printing temperature to 27.5 and do those first 6 runs, and then you only need to change it again once.
So if I had no knowledge that I would have to, I could do this kind of sequential DOE, and we should start over. And this is something I've seen multiple times, is people say, okay, well, I need to do a scientific experiment. I don't know where to start. But someone told me that I go to custom design, I load in all my factors, I just press the response sequence model, and I should do at least 53 runs.
Yeah.
And that's a lot. And
it's too many. Don't try and learn it all in one go. You can be much more efficient than that.
Yeah. And if something went wrong at run 2, you've just done 51 experiments where the measurement equipment was broken or something, right? So small and agile, I think, is what we're coming to.
Yeah, absolutely.
Interesting stuff, Phil. Thanks for having that discussion with me. I was actually trying to just emit temperature because it's such a pain. But I'll do it. I think it seems that this is actually doable now.
Yeah, like I say, changing these things only 3 times during the experiment is not ideal, but it's better than not having it as a factor at all.
Yeah, and that is the other alternative, is just emitting the factor. So
Right.
even though it's a compromise, we're still learning with that compromise. Well, the other alternative was not learning at all.
Yeah, I think I know which alternative I prefer.
Emitting it totally. No, that was me talking again. All right. Well, thank you. It's always a pleasure.
Thank you. Yeah, great example. Thanks.